Welcome to EDU World Space.
All right. So for this problem, we are given a circuit with two capacitors connecting in parallel, C1 and C2. They're in parallel. So we also know that C1 equal to C2 equal 6 microfarads. Besides, we know the voltage is 10 volts, right? It's 10 volts. So the question is, if we try to squeeze one of the capacitor, like squeeze the separation from D to half D, so we want to know the change of the charge. So to figure this out, we need to firstly determine the initial charge stored in the two capacitors. Because these two capacitors, they are connected in parallel, so the total capacitance C equals C1 plus C2 equal 12 microfarads, right? And Q, according to the definition of the capacitance, Q will be equal to C times V. C is the total capacitance and V is the voltage. So this is equal to 1.2 times 10 to the negative fourth coulombs. So this is the charge stored in the two capacitors. And if we squeeze one of the capacitor, then so suppose we squeeze C1, because for the parallel plate capacitor, C equal to epsilon naught A over D, where A is the area of the plate and D is the separation. So if we squeeze D from D to 0.5 D, then the C prime, which is the new capacitance, will be equal to 2C, right? So in this case, C1 prime equal to 2C1 equal to 12 microfarads. And C2 does not change. C2 is still equal to 6 microfarads. So the total capacitance C still equal to C1 prime plus C2, which in this case equal to 18 microfarads, right? So we can find out the new charge stored in the two capacitor after balance. So this will be equal to C prime. Sorry, this is C prime, right? C prime times V, because the voltage does not change. This equal to 1.8 times 10 to the negative fourth coulombs. So delta Q equal to Q1 minus Q equal to Q prime minus Q. So in this case, equal to 6 times 10 to the negative fifth coulombs.